All right, now let's plot some data. So if you don't already have an R script open one up. And what we're going to do is first learn about scatter plots. Now there are many different types of plots, many different ways to visualize data. And it's all going to depend on what types of data you're dealing with and what you think the best format for a visualization of those data would be. A very common one is simply a scatter plot, where you have points plotted on kind of against an x and a y axis. A very simple two-dimensional plot that R allows us to do in a very easy and straightforward way. Now, first we're going to need some data to actually play with. And so what I want to do is make use of the ArcData package. This is a package of real archaeological data that was compiled for the book Quantitative Methods in Archaeology Using R by the author David Carlson. As I said in a previous lecture, this is the only textbook that is currently out there for archaeology using R. And so what we need to do is install the package. You can do that using the install packages function and typing in ArcData. That's one method of doing this, and you can see that it's working there. Alternatively, you can go into the bottom right panel of your RStudio screen, click on Packages, click on the button Install, and then search for ArcData, spelled A-R-C-H data, all one word. Now that we have this package installed, as I said, I don't generally like to keep my install packages function in my R script, but what we do need to include is the library function for ArcData. This is the function that will call up that package now that we've installed it and allow us to make use of it in R. So once we run library ArcData, we now have access to the contents of this package. What I want to do next is inspect this package, and you can see here that if you run $ArcData, you're able to pull up the help page for this package, and you can scroll down and see all the different data sets that it includes. There's some really great real-world archaeological data sets in here, and you can see the reference right there. This is what we're going to be using a lot in this module. Specifically, right now, I want to make use of the ESA sites data set. If we pull up the help page for that, we can see that this is a data set of early Stone Age sites from Norway, 43 early Stone Age assemblages specifically. It's got the reference to the paper that these data come from. And what we need to do to call up this data set is the following. We need to use the data function in R and feed the data function ESA sites in quotation marks. This, once we run it, will load the data set ESA sites from the ArcData package that we've already called up using the library function. And now we see the ESA sites data set has appeared in our environment up here in the top right. We can scroll through that and see that it's got all these different columns, and they're all just letters, but we can see in the help page what these stand for. TA is for tanged arrows, BA is for blade arrows, and so on and so forth. So now that we have that data set loaded in, and we've gotten all of that working, let's inspect that data set. I like to start off with the call names function. I think this is a good way just to see what you're dealing with. As I said, if you click on it over here or type view and use the view function, you can open it up. But I don't like to generally keep opening and keep looking at the actual data table when I'm working with it. Once I look at it once, everything looks in order, I get a general feel for it, then I use more specific functions to investigate it. This call names function is what I use to see what the columns are that I'm dealing with. And so let's say that we wanted to create a plot of the, let's say, number of core and flake scrapers as a function of the number of microliths to see if there's a relationship between these two types of artifacts. So in order to make this plot, we can use the plot function in R. Let's pull up the help page for that so you can see what we're dealing with here. This is the default scatterplot function in R. You can read a description of it, that it's going to draw a scatter plot, and you can add a bunch of different things to this. The basic arguments are simply the data that will go on the x-axis, the data that will go on the y-axis. But you can add any number of other different arguments to this that we'll get into. But for the time being, it's that x and y that we need to know off the bat. If we scroll all the way down here to the bottom of the help page to look at examples of how to do this, you can see the different syntax that you would use to create such a plot, and run some actual examples with data sets that are built into R. We're going to be playing with this, as I said, ESA sites data set. So let's start off. As you can see in the help page, you need an x and a y variable. The x argument here is going to take ESA sites, and specifically the column CFS, as I said before. If we run just that by highlighting ESA sites $CFS and running it, we can see that it's a series of values that correspond to the counts for core and flake scrapers in these early Stone Age archaeological sites. The y argument then is what we're going to put on the y-axis, and that's where we want the column for microliths, which is simply $M. If we look at that, again, it's the same number of values, just smaller numbers and more zeros. And so this, right now, is a perfectly legitimate scatterplot function. Plot with the x argument being equal to the CFS column of ESA sites and the y argument equal to the M column. If we run this, we can see the plot that we've created here. We've got the M variable on the y-axis, the CFS on the x-axis, and these dots are showing the values for each of those plotted against each other. There are a couple different things that we can do in order to plot data using this plot function, however. The syntax that we just used is perfectly legitimate, and of course you don't actually even need to specify x and y, because x and y are the first two arguments listed in this function. So if you run just this, it will produce exactly the same plot, because it knows that x comes first, comma, y is second. It's the first and second arguments in the plot function. You can see that in the help page. However, I don't actually generally use this syntax based on commas when I'm plotting. I use what's called formula syntax because I'm working with models a lot when I'm doing statistics. And basically this syntax is a little bit different. Instead of saying ESA sites CFS comma ESA sites $M, we're going to switch the order. Instead of having it x comma y, it will be the y variable, and then we're going to use the tilde, which you can get, it's on your keyboard, it'll be to the left of the number 1 if you hit shift. And we want to plot ESA sites M as a function of ESA sites CFS. This tilde symbol here can be read as a function of. This is going to become very commonly used later on in this module when we get into modeling. But for the time being, you can understand this as the y-axis variable as a function of the x-axis variable. This makes sense when you remember that the predictor variable tends to go on the x-axis, and the response variable goes on the y-axis. Similarly, independent and dependent variables, if you're more familiar with that terminology. So when we're talking about M as a function of CFS, CFS is the predictor and M is the response. That's why M is a function of CFS. CFS is what is being used to predict M. So that's why this order is reversed from the basic plotting syntax. Additionally, we don't actually need to specify ESA sites $M and ESA sites $CFS. The plot function has another argument built into it that's really useful, where we can simply specify plot M as a function of CFS and add a new argument. Because if we left it at just M as a function of CFS, you'll see that in our environment there are no objects called M or CFS. So running simply this would produce an error and would not produce a plot. It doesn't know what we're trying to do. We need to add another argument called data. And if we say data equals ESA sites and run this, then it will produce our plot for us. This is just a slightly more efficient way to say the same thing that we've said above. M as a function of CFS, pulling those two vectors from the data, from the ESA sites data frame. And this is the syntax that I generally like to use when I'm creating plots. It's just a little bit cleaner, a little bit more efficient. It looks nicer, much more neat. So now that we've got that basic plot function down and all the different ways that we can do it, we can next start to unpack all of the different extra things that we can add in to this plot function.